This lesson is an introduction to searching and sorting. Perhaps you're in grade 11, you're seeing this for the first time, or maybe you're in grade 12 and we're using this as a review lesson. So here we are, searching and sorting. This is a grade 11 lesson. It's a review for grade 12, and it's a required knowledge for what we're doing next in grade 12 as well. So do you remember that we can store a collection of information in a list or an array? So in Python, we used lists. In Java, we used arrays. Now, the collection of information in each one of those things, each one of those structures, usually has to be the same type. So usually we're talking about all integers or all strings and so forth. In this case, with searching and sorting, we're going to be talking about primarily integers only. So we'll be talking about searching and sorting integers just because they're the easiest to work with. The algorithms we'll be seeing will still be valid for other types, even objects or strings or other types of information like points, if you're getting into the Java point class. But integers, it's an easy way to see the algorithm for the first time. And when you look at computer science textbooks, they pretty much just look over integers. So here's a real-world example. I know I just finished talking about integers, but because it's a real-world example, I want to talk about CDs. And I don't know if anybody still uses CDs. When I first started teaching this, everybody definitely used CDs. I know the iPod Nano and the iPod Shuffle were out at that time, and nowadays there are 1,000 different devices that you can stream, probably just your phone, right? But anyway, everyone's familiar with the whole concept of music on a disc, and that case has the name on it. And it's kind of neat because you can physically take it, or if you have record, maybe you have a record collection, maybe your parents or grandparents have a record collection that you're lucky enough to see. It's just different type of technology, much older. So what I did is I said, okay, let's take a bunch of CDs and we're going to represent the title, so maybe the title of the album, and just take the first letter title of the album. So this one over here, the name is for C, for example. So maybe it's an album that starts with the word chaos or something, and so forth. Okay, so these are the names. So we want to search for a specific element. So let's just say, let's go back here, and we asked a robot or a computer to search through this list and find our CD that starts with the letter A. So they would search through, they would start with a C, so there would be a pointer, we'd be going to C, that's not it. It would search for the next one, T, that's not it. And then it would find a match here, and it would say, oh, I found it, I found one. And then you would, in your algorithm, you would say, well, exit the loop or exit the search as soon as you find the first CD with A, or maybe you want to keep going and find all of the CDs that start with the letter A, where the title starts with the letter A. And that's something that you'll have to decide. So searching for a specific element, if the list is not sorted, we really have to examine each element in the list because we don't know anything about how the list is structured. So if we knew it was in alphabetical order, then we would know it would probably be, if we were searching, let's say for an album, Led Zeppelin, and maybe it was Z for Zeppelin, right? So maybe we would have to, we'd say, okay, it makes a lot of sense to start at the end of the list because of the Z, it's at the end of the alphabet, if it was sorted. But if it's not sorted, we can't really say anything about the structure, so we don't know. We're just going to start at the beginning and work our way through, slog through it, and see what we find. And that's what we're doing in this particular searching array, searching algorithm. So once again, an algorithm is a set of instructions to do something. So let's say that you had a robot, it's the future, and you're going off to work and you're telling the robot to clean the house. Maybe you're going to be able to just, maybe it's going to be like Alexa or Siri, and you're going to be able to just say, okay, I want you to clean this room, the bathroom upstairs, I want you to clean the second bedroom and the third bedroom. Don't clean the master bedroom because there's too many things on the floor, and we need to do that ourselves because there's too many things, and we need to put everything away first before you do any vacuuming. Maybe, okay, so that you're giving your robot in the future an algorithm or a set of instructions, a very high-level set of instructions, very to do something. In this case, our searching algorithm is going to say, well, search for D in the following array or list. Whenever you see array, that's also a list. It's the same thing. It's just a different word for it. Different programming languages call it different things. So we're searching for D in the array. Here's what the algorithm that we would program would say. It would say, start at location 0, and then go successively every step. Don't miss any of them. And if you found D, report back, but continue to go, and then stop once you get to the end. As soon as you get to the end, do the last one, and then stop. And then report back all of the locations where you found D. And in this case, it would go forward and it would say, oh, I found D in location 1, and I also found D in location 4, and that was it. That's what the program would report back. All right, so here's that same example, the same list or the same array and all the locations. Remember, and this is a key point from our previous unit, or one of our previous units anyway, if there are 8 elements in the array or the list like we have here, because we start counting at location 0, you can only access up to location 7 when there's 8 locations or items in your list or array. So just keep that in mind. It's a really key point. So here we go. This is Python. If you're in Java, you can easily translate this to Java code. So Sentinel is just something that is something you're searching for, or I think that in the olden days, a Sentinel was a person who went ahead, kind of like a scout, to look for something, or like a guard that was there. So it was the first person that you would see, maybe. But in our case, it's the value that we're looking for. So it's our first. That's really all we care about. So we have a for loop that goes from 0 to 8. Remember, it doesn't actually, when it gets to 8, it stops. And if the list at location count, so count is our stepper, it's going to be going from 0, 1, 2, 3, 4, 5, 6, 7. If the list at that location is equal to Sentinel that we're searching for, print found at location count. And it's going to go through for every one. And it's going to compare every location to see if it's the correct value. And if it finds it, it will print that. It'll say found at location and then that value of count. So that's our most simple searching algorithm that we have. And that's really the only one that we can use that we'll be talking about, as long as the list is in random order and you don't know what it's all about. Okay, moving on to sorting. It is going to be important to sort lists or arrays. And the first algorithm we will be looking at is called bubble sort. So bubble sort is one of the first algorithm that most people learn, and that's why I'm going over it with you first. And this is how it works. We have our list or array. We're trying to sort it from lowest to highest. We would like, let's see, what's the lowest value? The 1 is the lowest. We want it to be on the left side, the very far left. Then we want 2 to come next to it. Then we want 3. So you can think of a toddler or someone who knows their numbers already, maybe in senior kindergarten or grade 1, and you have all these blocks and they're all organized like this, counting blocks, and you say, okay, I want you to put these blocks in order from lowest to highest. And maybe you can time them. They can have a game about it and see who's quicker, who can sort them in the quickest amount of time. This is what bubble sort does, but because it's a computer, it's not as smart as a human being. It's not even as smart as a toddler. It needs to compare things and go through. It needs very specific set of instructions. Very specific set of instructions. This reminds me of a Charlie Brown book I just read to my kids, and it was all about how Marcy, who's the one with the glasses, she's a little bit clueless, and Peppermint Patty and her are trying to make Easter eggs. And I'll just quickly go over this story because I think you'll maybe appreciate and put it in its perspective. And so what happens is Peppermint Patty says, okay, I'm going to go mix the dyes, and you, Marcy, I need you to boil the eggs. So what she does eventually, after a few tries, she keeps getting it wrong, and finally what she does, she cracks the eggs. She puts all of the eggs into a big pot of water, and she says, okay, I'm boiling the eggs. And that whole Marcy character on Peanuts, Charlie Brown, that's how you can kind of think of a computer when you're programming it. Computers are so literal. They do exactly what you want them to do. They don't do anything more or anything less. And in fact, you have to explicitly say every single instruction or else they'll get it wrong. Okay? So this is how, this brings me back to bubble sort now. So what we need to do, here's this specific algorithm they came up with that ensures that even a computer, something that is as clueless as a computer, is able to sort a list. So what we're going to do is we're going to go through the values pairwise. I want you to think of this double-headed arrow as, the double-headed arrow is like a slider. So it can be slid across, and we're going to be comparing the 5 and the 3. If they're out of order, swap them. So that's what the instructions say. Go through each pair of elements. If they're out of order, swap them. So we're going to do the 5, 3. 5 and 3 are out of order, so we're going to swap them. Then it's going to go to the 5 and the 9, because remember, they've been swapped. The 5 and the 9 are not out of order, so we're not going to swap them. Then we'll go to the next set, 9 and the 1, and see if those are out of order. Now, we're going to only do this 7 times, because if we did it more than 7 times, something would happen. You can pause the video and ask yourself the question, why only 7 times? Okay, so hopefully you had a chance to think about that. It's only 7 times because we're comparing them pairwise. So by the time we get to the end, it's the last 2. So if you take 2 fingers and just compare 5, 3, 3, 9, 9, 1, 1, 10, etc., all the way up to 4, 2, even though there's 8 values, there's only the possibility of pairing 7 things that are adjacent to one another. Okay, that's why it's only 7 times. And we can talk about that more in class. You'll see it here. So here's an illustration of how we're doing the comparing. So we compare the 5 and the 3, find out that they're out of order, so they get swapped. The 3 goes where the 5 was, the 5 goes where the 3 was. And you can see that reflected on the second line. Then the 5 and the 9 are compared, nothing happens because they're in order. The 9 and the 1 then get compared. They get swapped because they were out of order. Now the 9 and the 10 get compared. 9 and the 10 are not out of order, so then we're going to go to the next thing. 9 and 10 stay. The 10 and the 3 get compared. They get swapped. 3 and the 10. So now it's 3, 10. Now the 10 and the 4 get swapped, so they become 4, 10. And then the 10, and you can see that the 10 is kind of like the big bully here. It continues to win right up to the end because it's the largest number. So in general, the way bubble sort works, the way that we've implemented here is the largest value has been bubbled up to the top or up to the end. And usually, I think the first time I saw this, all the values were vertical, and they were bubbling, they were comparing, and the smallest value is winning. And that's also a valid implementation of bubble sort. It'll still sort them, it'll just sort it in a different way. And in that case, the smallest value, because it's the lightest, gets bubbled up to the top in that particular case, in another example I'm talking about. And you can see why it's called bubble sort. In our case, the largest value is bubbling to the top or the end. After this, the list is now partially sorted. And now we have to go through the process another 6 times. And why only 6 times? Think about that and see if you can come up with an answer on your own. You can pause the video. Okay, so you've paused the video, you've thought about it. We have 8 values. We were able to do go through once. After going through once, one iteration or one pass of the algorithm, the 10 is now at the end. The largest value is done. We no longer have to take a look at that value. So now we only have 1, 2, 3, 4, 5, 6, 7 values. 7 values left. Why would we only have to go through 6 more times if we only have 7 values left? Well, think about it this way. Each time that we go through, we're going to continue. The largest remaining value is going to win. So next time around, the 9 is going to be bubbled to the end. Then we're going to get the 5. By the end of this, the poor 1, who's the weakest one of all, has been pushed to the front. So we don't need the 1 to do any comparisons with it. We already know that the 1 is in the correct place just by default. Okay, so the last pass does not have to be done. Okay, so here's some I guess, pseudocode or some language that can help you start thinking about how you might program this. And here's the set of instructions in a bit of a more specific way. So let n be the number of elements in the list in general, because we don't know how many elements the user will give us. So let's say they give us 20 elements. Maybe they give us 20,000 elements. N is the number of items. In that case, we need to go through n minus 1 times. We need to go through n minus 1 passes of the algorithm. And we don't have to do that last pass, because at that point the smallest value will already be on the left by default. All right, here's a swapping algorithm. So let's say you wanted to swap two variables. Variables int a and int b have values. Okay, so int a and int b are the ones we're trying to swap. Int temp, we're going to have to use another variable called int temp, because let's say that we just copied the contents of int a into int b. Let's say we did that. So whatever int a was, let's just switch over here to, I'm going to switch to something else so you can see what I'm doing. This. So here you can see it graphically laid out. Step 1, we're going to copy int a into int temp. And then we're going to, step 2, copy int b into int a. And then finally, step 3, copy whatever's in int temp into int b. Here, the classwork is going to be up on our online learning, D2L, or whatever we're using this year. And that will be for grade 11s. Grade 12s, this was an introduction, and I'm going to have some other classwork for grade 12s as well.